Today we're diving deeper into 5 additional terms that you'll encounter constantly when working with DNA matches and family history research. Don't worry if these concepts sound intimidating. We'll break them down into simple, easy-to-understand examples. By the end of this episode, you'll understand the different types of DNA tests and why DNA inheritance can sometimes produce surprising results. Many beginners think DNA testing is simply about finding matches. But interpreting those matches requires understanding how DNA moves from generation to generation. The 5 terms we're covering today explain why your DNA results look the way they do, and why DNA sometimes confirms family connections and sometimes doesn't. These concepts form the foundation for everything you'll do in genetic genealogy. Autosomal DNA is what most people receive when they test with companies like AncestryDNA, 23andMe, MyHeritage, or FamilyTreeDNA. Think of autosomal DNA as a giant mixture of DNA inherited from all of your recent ancestors. This is the test that generates cousin matches and powers most family history discoveries. Because autosomal DNA becomes diluted over time, it's generally most useful within the last 5 to 7 generations. This is one of the most surprising concepts for beginners. Although everyone has the same number of genealogical ancestors, we do not inherit DNA evenly from them. Think of DNA inheritance like dealing cards from a shuffled deck. Each generation receives a random selection of DNA. As you move farther back in time, some ancestors leave large DNA contributions, while others leave none that survive to the present. This explains why DNA tests cannot identify every ancestor in your family tree. Recombination is nature's way of shuffling the genetic deck. Before parents pass DNA to their children, chromosome pairs exchange pieces of DNA. This creates brand new combinations that have never existed before. Because of recombination, siblings receive different DNA from their parents, even though they share the same mother and father. Without recombination, all siblings would inherit identical DNA. Many people are surprised to learn that siblings do not inherit identical DNA. Although they receive DNA from the same parents, recombination creates unique genetic combinations for each child. This is why one sibling may match a distant cousin while another sibling does not. It's also why testing multiple family members can be incredibly valuable in genealogy research. Y-DNA is very different from autosomal DNA. It follows one specific path through your family tree, the direct paternal line. A father passes his Y chromosome to his sons, who then pass it to their sons. Because surnames often follow the same path, Y-DNA can be extremely useful for surname studies and lineage verification. Females do not inherit Y-DNA, but they can test a father, brother, uncle, or other male relative to explore that paternal line. Mitochondrial DNA, or mtDNA, follows the opposite path of Y-DNA. Everyone inherits mtDNA from their mother. However, only daughters pass it on to future generations. This means mtDNA traces a single maternal line through your family tree. Because mtDNA changes very slowly, it is particularly useful for studying deep ancestry and maternal line connections. Think of these tests as different tools for different jobs. Autosomal DNA is the broad survey tool that examines all recent ancestral lines. Y-DNA zooms in on one direct paternal line. mtDNA zooms in on one direct maternal line. Most beginners start with autosomal DNA because it provides the largest number of matches and the greatest potential for family history discoveries. Today we learned 5 essential concepts that explain how DNA is inherited and why your results look the way they do. Understanding autosomal DNA, random inheritance, and recombination helps explain why DNA matches appear, or sometimes don't. Understanding Y-DNA and mtDNA introduces the specialized tests that can help solve specific genealogy problems. As you continue your genetic genealogy journey, these concepts will become the building blocks for interpreting matches, evaluating evidence, and making family history discoveries. Thanks for watching, and I'll see you in the next episode.